Welcome to topic 8 of data science, and this topic has two subtopics, and those subtopics are the equation of a straight line and a simple linear regression. Okay, so there are some different types of regression. We're going to look at the first type to learn, which is the simple linear regression. So first of all, the equation of a straight line. Now, I've put some additional information that's available to you here. If this is a new topic to you, that'll be available just in this PowerPoint. So first of all, the equation of a line. So the equation of a straight line is usually written with the formula y is equal to mx plus b. Okay, now in the UK, we call this y equals mx plus c. And in America, they say y equals mx plus b. So many examples you find online are going to say y equals mx plus b. However, if you find examples from the UK, they're going to use c. But whatever they use, b or c, it means the same thing. Okay, so the equation of the line is the y, the value of y. And if you imagine if we plotted out our x and y coordinates, okay, and these were positioned on a graph, okay, the value of y is equal to the slope of the line multiplied by the value in x plus b, okay, and b is the point at which the line crosses the y-axis, okay, it's called the y-intercept, and m is the slope of the line, okay, and the slope of the line is calculated by the rise divided by the run. Okay, so how do you find m and b? Okay, so let's say we want to calculate y for some x. We need to know what m is and what b is. Okay, so b is easy to find. All right, it's just the point that the line crosses the y-axis. Okay, it's called the intercept. So that's an easy one. So on this example that we have here, okay, down here is the point at which it crosses the y-axis. Okay, it looks to me like the y-intercept on this line. Okay, if you imagine if that's 0, that's -1. Here would be -2. Okay, so -2 would be the y-intercept. All right, so y would be equal to mx plus -2. Okay, now the next thing we want to do is calculate the slope of the line. Okay, and so we take the rise of the line. Okay, so the rise is going up 2 here. Okay, and divide that by the run of the line. Okay, so for every up 2, it goes along 3. Okay, think of those like steps, climbing up steps. Okay, so 2 over 3. That should be a 3 there. Okay, so that's how we calculate the slope. So if we know y is equal to the slope times x plus the y-intercept, then we can calculate y. Okay, so for any given x value, we can calculate the value of y using this formula. Right, so here's an example line, and we have the rise of 2 and the run of 1. Okay, so m, the slope on this line, would be 2 divided by 1. 2 divided by 1 is an easy thing to do. Anything divided by 1 is just itself. Okay, so the m is 2. And then the y-intercept, the point where the line crosses the y-axis, is 1. Okay, so the equation of this line shown in the graphic here is y equals 2x plus 1. Now that we've seen the formula of a straight line, y equals mx plus b, what I would say is that in statistics, they don't use that formula. Well, they do use that formula, but they call it something different. Okay, so what they do is they use a formula called y equals beta 0 plus beta 1x. Okay, this actually in the UK, people used to pronounce this beta. Okay, so maybe if you hear any older people in the UK, they would call that beta. You used to get a type of a video cassette recorder called a Beta Max. Okay, but generally people just call this beta now. So y equals mx plus b can actually be written y equals beta 0 plus beta 1 x. Okay, and it's quite straightforward swapping them over. Okay, y is still y, right? So that's fine. Okay, but what we do is we swap these round, right? So if you imagine that we're now writing it as y equals, okay, b plus mx. B plus mx is the same as mx plus b, right? Whether these are just two things being added together, okay? So then let's say, okay, that we're, instead of using the letter b, we're going to call this beta 0, okay? And instead of using the letter m, okay, we're going to call that beta 1, okay? So the formula can be written y equals beta 0 plus beta 1 x, okay? Now, the variables in this equation, okay, are given names, and we can call the y variable as the dependent variable, okay, and the x variable as the independent variable. Sometimes x is called the predictor variable. Now, it's convention when you're plotting data to put the dependent data on the y-axis. So if you think the value of y depends on the value of x by convention. Now that we understand the equation of a line formula, or we've at least had a look at it, we can now look at this next topic, which is regression. Consider this example scatter plot. Okay, this just means a kind of a dots have been plotted in on a graph, and they're kind of scattered around. So it's called a scatter plot. And we have running down the side here, okay, some values. Okay, 10 values, 10 entries. Okay, so n would be 10. Okay, number of records is 10. Then we have some value in sales, which could be dollars, could be thousands, could be pounds, could be euro. And then we have some value in advertising. Okay, and this could be hundreds, thousands. There could be a correlation between those two. All right, now what we could do is we could take all these values and then we could put them into an equation, and then using that, what we could do is, if I said to you, we spent this amount on advertising this year, what do you think the sales would be based on the previous data we have? How do we do that? Well, what we do is we draw a line through the points in the data set, okay? And what we try and do is we try and find the line that best fits. And if you imagine, if we can find the best fitting line in whatever direction it's traveling, then we should be able to plot further points on that line based on the current trend of the line, based on the slope of the line. Okay, and the way that we can do this is with an equation called the least squares equation. Now, I've tried to put some graphics to illustrate this one in particular. Okay, so if you imagine each point on the line has a square drawn around it, okay, if you took the size of all those squares and you wanted to make them, you make them all as small as you could. Okay, so how can you get a line through there, or which direction and which point would the line cross that would mean that these squares are as small as they can be? Okay, so to do that, we use a formula. What I've done to illustrate this is I've come up with an example data set. Now, hopefully this is a similar idea to the data set that we looked at last time, where we had characters from the game. Each character had a particular weight and a height, okay? And we calculated in the previous class the correlation between these two values. What I've done in the graphic on the left here is I've just tried to guess roughly what a best fit line would look like. Let's say that we want to calculate this best fit line, and we want to work out how to get this, right? What we're going to do is we're going to first of all have to calculate some extra information. So I've come up with a little example spreadsheet that shows how to do this here. Here are my n values here. Okay, so we have values 1 through 10, and then we're going to give height the x variable. So height is going to be the predictor of weight. Okay, and then what we're going to do is we're going to first of all calculate the x squared values. So the first x value is in B2 here. So if we just do equals sum, okay, B2 times B2. So it's worked out the x squared value there. Now what I'm going to do, okay, is just grab that and drag it down here. Okay, and that's going to give us all the x squared values for 1 to 10. Now the y squared values, okay, are going to be the same formula. Let me just copy this formula, but we'll change it to C times C. Okay, instead of B2 times B2, it'll be C2 times C2. So let's do C2 times C2. Okay, and that's going to give us the y squared value. So 8 times 8 is 64, 80 times 80, 6400. Okay, so let's drag that down and fill out the y squared values. Now, this column here we want to calculate is the cross products. Okay, so x times y. So that would be equals sum, okay, and then we would do B2 times C2. Okay, so that gives us our cross product, and we can see the kind of orange and purple highlight in there. So let's get the cross product, and then let's calculate them for all values. There we go. Now, the next thing we want to do is work out the totals. So let's do B2 to B11. That'll give us our 10 totals there. Okay, and then what I'm going to do is just drag that formula along, and that'll give us the total values for all of these. So now we have the sum of x, the sum of y, the sum of x squared, the sum of y squared, and the sum of xy, the sum of the cross products. Okay, so let's head back over. I guess that these should mirror each other. Let me just do a quick bit of testing. So the last value in was 5985. Let's just check that's 5985. Yes, 5985. Okay, I'm not going mad. Right. So first thing we need to do is calculate x squared, y squared, and then the cross product. And then once we've done that, it's easy enough to calculate the sum of these values. So the first thing to do when we want to get, okay, the formula y is equal to beta 0 plus beta 1 x, okay, is we're going to find out we're going to calculate beta 1 first, okay? So beta 1 can be calculated, first of all, by taking the sum of the cross products minus the sum of x times the sum of y over the value in n. Okay, so let's work out the top half first. Okay, so I'm just going to jump over to my spreadsheet here. So we need for beta 1, and you know what I think I should probably do? Probably get these side by side. So just give me a minute to arrange my windows here so we can see both. So let's fire that one over there, and let's pop this one just about here. There. So we can see the formula and we can see the spreadsheet on the same screen. And let me just make that a wee bit smaller and go for 100. There we go. Okay, so to calculate beta 1, right, let's take the, and let's just fire this into a calculator. So bring up a calculator as well. Right, here is my calculator just in basic mode. in the middle here. So we're trying to try and work out beta 1. Take the sum of x and y, which is 1, 2, 1, 1, 8, 4. And that's going to be minus the 1681 times 708. Okay, and then we're going to divide that by 10. 1681 times 708. And that's going to give us that value there. So let me just, and we might as well divide that by 10 while we're at it. Right, so that's going to give us this number. So let's just delete that, pop that in. And then let's work out that value, which is going to give us that. Now let's work out of B1. So it should be that minus
this one,
that, which is going to give us that number there. Then what we want to do is take that value on the top and divide it by the bottom value. So let's just put that there and do divide. Okay, what I'm saying now is, and we'll round this up, okay, so we'll say that beta 1 is 0.75. Now to work out beta 0, okay, so move forward to the next formula, and beta 0 is 0.75 times the sum of the values in x, so 1681. And that's going to give us that. Divide that by 10, it's going to give us, so now what I'm going to do is I'm going to do the sum of y, so 708 minus that, 581. Now let's do 708 minus that.
Yeah.
Gives us that. Divide that by 10, gives us minus 55. So we're saying that beta 0 is minus 55 point, let's say point, let's just call it minus 55. All right, let's not do it. Oh, okay, 0.27. So let's say it's minus 55.3. Okay, so what my hypothesis after this would be that the formula for this line would be y is equal to beta 0, 0.5, which is 55.3, negative 55.3, okay, plus 0.75 x
times x. Yeah.
Okay, so now let's go and see if that works, and that gives us a proper calculation in our fourth step here. So someone's come in and they have a height of 150. So I'm going to plug that into the equation of a line formula. So that would be y is equal to minus 55.3, okay, plus 0.75 times 150. So let's do 150 times 0.75 first. And that's going to give us 112.5. Okay. Now we need to do minus 55.3 plus 112.5. 57.2. 57.2 would be that person's predicted weight in kilograms, and that looks about right given the information we've got, because look, there's someone who's 156 centimeters and they're at 60, so 57.2. So try another example, right? Let's say someone comes in, and we'll do a deliberately silly one, okay, and they are 250 centimeters tall, so a giant basically. Okay, so y is equal to minus 55.3 plus 0.75 times the value of x, which is going to be 250. So first of all, what we'll do is we'll do 250, 0.75 times 250 to get the value on this on the end there. So it's 187.5. And then it's just minus 55.3 plus 187.5. And that value is what we have in y. So based on the data we have, we can predict that their weight would be 132.5 kilograms if they were 250 centimeters tall. is how we calculate the least squares equation. That's how we calculate the equation of a line given a data set. Let's have a look at plotting this in Python. How do we actually plot this out in Python? Well, it's actually really straightforward. Once we have the data in the CSV file, using NumPy, we can just plot this and PyPlot. We can just plot this passing PyPlot a value for X and a value for Y. PyPlot understands that there's rows of data and the values are in the data. So this Python code here will give us a really simple plot, but moving forward, right, if we add a little bit of extra code, okay, to this and use a thing called polyfit, it will give us this, the best fit line, okay? And I've added an example function, a numpy.polyfit there, and that'll show us how to do the best fit line. So what I've done is I've actually added to the middle page, okay, some notes on this, okay? So if you were unsure, if I went a bit fast there, or if you were unsure of where I went wrong or where I went right, I kind of wanted to trip up a little bit in there so that we could try and fix it. I've added some notes that just cover exactly what I've just been through in a bit more detail, and the formulas are in there too, okay, to the middle. But this week's task, you'll be pleased to know, there's no Jupyter Lab, all right? We're just doing a linear regression calculation. So just exactly what I've just done there, except we're going to calculate this for a company that I've made up. So we have a company and we have 4 years of data for this company. Now, in year one, they spent 1,000 on advertising and they made 4,000 in profit. In year 4, they spent 7,000 on advertising, okay, and they made 1,100 profit. So what I would like you to do is calculate the mean trend line equation using advertising as the independent variable and profit as a dependent variable. So what I would like to say is, let's say, okay, the company spends 25,000 on advertising. Given the data that we've got, what would the profit be? Okay, and then all I want you to do is modify this Python program to display those results in a graph. Okay, now you can do that in Jupyter Lab if you like. I don't mind how you make the graph, just the graph to come out, and just add that to the ePortfolio.